This is for year 11 methods. We're going to look at question 1b from exercise 2e. So it says find the equation of a straight line which passes through the point 4, -2 and is perpendicular to the line y equals 2x plus 1. Okay, so if I were to visually draw what's going on, we've got a line y equals 2x plus 1. So we've got a y-intercept at 1 and an x-intercept of a half. So it roughly looks like that. What we're trying to do is we're trying to find a line which is perpendicular to it. So it's at 90 degrees to that original line, okay? So what's the relationship between the gradient of this line and the gradient of that line? Well, I know that the gradients of perpendicular lines, the product of them, so m1 times m2 equals -1. So if I rearrange, m2 would equal -1 divided by m1. The shortcut I can use is I know that m2 is just the original gradient, because my original gradient's 2. I flip it, so it becomes 1 on 2, and I change the sign. Okay, so this is the gradient of the perpendicular line over here. Okay, so how do I get the equation? We know y equals mx plus c. Okay, my m I already know for the perpendicular gradient's -1/2, so I'm just going to plug that in. I just need to find my c value. Okay, so to get the c value, I sub in a point that the line passes. You notice how both lines have that in common, that point in common. So all I need to do is sub that point in. So it'll become 4, -2, and sub it in. So -1/2 of 4 is -2. -2 plus 2. Great, it just cancels, so c equals 0. So all we need to do is we need to write the equation of the line. So y equals -1/2x plus 0. So it's just -1/2x. So the line that's perpendicular to that line would be y equals -1/2x. So hopefully that helps.